In this video, we're going to take a look here at how we can look at a vector function and understand kind of what sort of a graph it would create, right? What does this graph look like in 3-space? We said at the start of this section that we're going to be interested in lots of various different types of shapes and kind of expanding off the idea of a line. So you could imagine almost doing something silly like drawing out paths in space in front of you. Like maybe imagine right now that you were to throw a paper airplane out into the room in front of you, right? And maybe that paper airplane is going to like dip or go up in the air, and then maybe it will dip down, maybe it'll spiral in a circle briefly. And if you could like trace its path throughout space with a curve, you might get some really crazy weird picture that happens to maybe say look something like this. You know, maybe it goes and like spirals down and hits the ground. Well, this here could be the picture of a vector function in 3-space. And so we're going to try to use our 3D plotter to help us understand how we can imagine this vector function producing this sort of a curve. How does it actually work? Okay. We said that the inputs of our vector functions are going to be values of t, and the outputs of our vector function are vectors. So how do those things go together to make a graph? All right, let's take a look here at example 2. We have seen in a previous section that the parametric equations for a line that passes through these 2 points were given by these 3 formulas. You might be able to look back at our section on lines and actually find this example there. Okay? But this question here asks, how exactly would we go about representing this line as a vector function? Okay, well, this is actually really easy here. If I wanted to turn this into a vector function, I could just notice that I have already a formula in terms of t that represents the first component, the x component of a vector. So really, I can just go ahead and take my x formula and put it here, my y formula, put it here, and my z formula and put it here. I've created a vector function. And I know that this vector function should look like a line. So how does that work? Let's go ahead and move over to the 3D plotter. Remember, there's a link to that in Blackboard, so you can try to do this on your own and follow along. But let's see what we have over here. All right, on the 3D plotter, I'm going to go ahead, I'm going to erase whatever graph was up there by hitting that little X, and then I'm going to go ahead and create a space curve. This is a vector function. You'll see the r of t listed right there. Now when I do this, you'll see that it's going to bring up for me an x of t, y of t, z of t, or what we've called in the last video our f, g, and h of t. These are our component functions. Now if I was to type in the component functions that we had on this problem, you can easily see that after I hit enter and I graph that, I do indeed get the graph of a line. You can use your arrow keys again to spin this around so you can get a sense of kind of where this line is in terms of your x, y, and z axes. Okay, so I have my line kind of floating around out here. Now, the weird part is, how do I understand how that vector function took in inputs and outputs to create this line? Well, to see that, I'm going to go ahead really quickly and I'm going to go ahead and change the range on the values of t here. I'm going to change this to -1 to 1 really quick. Okay. You'll see that when if I do this, let me make sure that this is working okay. There we go. I had to hit enter there to make sure that that actually got submitted. But you can see here as I change these values of t, what t is corresponding to, if I use different values, is ranges essentially on how much of the line is going to get sketched at any one time. So you'll see here that as I manipulate the different values that I'm going to use here, I either graph more or less of the line. This is very similar to what happens in an algebra class. If you use more values of x, more input values, you typically get to see more y's on the graph. So here, when I actually use more values of t, what I'm getting out is more vectors. So why don't I see vectors in the picture? Here's the cool thing. Click the trace button down here at the bottom, and what you will see being added into the picture is a really important vector right here. So notice that right now I'm at the trace point where t is 0. This says if I plug in the number 0 into for t, notice that I'm going to create the vector. It should be vector -2, -3, or sorry, +2, -3, 4. And if I graph that vector, that actually is this blue vector right here. And notice that that blue vector is pointing exactly to that point. And if I was to kind of grab this slider, you can see that as I plug in different values for t, I have a vector that points to different points on that line. So I kind of imagine a vector function as creating these blue vectors that in a sense are kind of shooting out these little points in space, and then those points all essentially get connected when there's enough of them. So I have to imagine a vector function as like almost like a gun sitting at the origin shooting out points. And what does the shooting is the vectors that we create. This is why when I get rid of this, I don't actually see any vectors in the picture, I just see a line. But when I add this in, I can see the vector that shoots out any given point. So what we'll notice again here is that t is a very important piece of the puzzle. T, my input value, is going to allow me to produce different vectors. And so with each individual point that is on my graph, I'm imagining that there's a value of t that gets me there. This is why we often think of graphs in this section as kind of being able to represent motion via time. That is, more motion over time. So like if I imagined that there was a car, say, traveling along this path, or a particle or something like that, I could say, hey, when is the particle exactly at this point in space, right? Right here at this dot. And I would say it's there at 1.08 seconds, right? That's when it's there. And it gets over here at 1.72 seconds, right? And so I can imagine kind of this t as describing in some sense a unit of time. Of course, that can be a little weird in some applications if you start to have t go negative, but we of course can maybe just try to imagine another interpretation of t. T is known as a parameter in a parametric equation, which is what we kind of have going on here. So this is a little bit about how these vector functions work, and in some of the upcoming examples we're going to see how we can actually again take different vector function formulas and maybe try to predict or actually sketch a graph of what that vector function might look like without using the 3D plotter.